So this video is going to discuss how to create a function block diagram. So what I have set up here is I've already have my RS Logix set up, and I have my compact logic. I'm using the 1769 L23E QB1 compact logic, and I just loaded up my integer program I had used before. So I'm just going to come up here and I'm just going to change the name of this. So this is just going to be a function block example. So I'm just going to change the name of the program there. And then you can see here I have already added my relay module, and I've added my analog module. Let's double click on the analog module. We can look at our configuration. Taking a little bit to load here. Alright, and so we can see that I have these actually hooked up. This is actually hooked up to my integrator circuit. So I have the 4 to 20 milliamp redline converters feeding this. One's measuring a voltage and one's measuring a current for the load resistor, the 5 ohm load resistor. But so those are enabled, so we can use those. But I'm just going to start off with a standard fill-in circuit. So if we come over here to our program tags. So now notice here I'm under main task, main program, and that's where I've declared my tags. Now you can declare tags either under programs, or you could come up to your controller and you could define controller tags. Now what we're going to do here is we're going to be creating a subroutine under the main program. And so therefore any tags that we create under main program will be available. Now if we wanted to, we could create a brand new program. So if we come up to main task, you can actually create a completely different program. And if you create tags under controller tags, those tags have what they consider a global scope, which are available to any program in any task. But if you create them under a program, those tags will only be available under that program. So that's what they refer to as like a tag scope and where the tag is available at. So I'm going to come over here to my program tags and edit tags, and you can see I actually have quite a few tags already defined. So I have like my amber light, I have my red light, I have my white light and green light, which each one of those lights are connected to the relays. So those are connected to the relay modules in module 3. And then I also have a start switch, my green start switch, which is a DC input 1, and a red stop button, which is also there. I also have some virtual relay, virtual start stop, okay, and then I have the voltage tags. I have the actual analog input, which is a 4 to 20 milliamp, or technically when it's set for engineering units, it's a microamp reading into the analog card. And then I have a voltage, which is a real value for scaling that back into a true voltage, and some other tags already created in here. So I already have these tags created. What I want to do is I'm just going to start off by building a fill-in tag. But I'm not going to create it in my ladder logic program. So I'm going to come up here to main program, right click, and I'm going to say new routine. Now this here is going to be a function block. seal-in. So we're used to ladder logic seal-ins, and honestly, ladder logic seal-ins are the most efficient and probably the best way of doing it. But here I'm going to show you how to do a function block seal-in, just to show you, because you're familiar with the seal-in circuit. So this is going to show you the relation and how that works. And so I'm now going to select this under type instead of ladder logic, which was the default. I'm going to actually select that as a function block. And so I'm going to click OK. So now you see that I have a new routine here called function block. And so in here now, I get this kind of just blank sheet, tabula rasa going on here. And I'm going to come up at the top. Now, if you notice up here on your toolbar, they're different from what they were before. But if you notice here, we have an input reference. So I'm going to come here, I'm going to click on this input reference, and I'm going to have my start button. And then I'm going to grab another one, which will be my stop button. And then I'm going to grab the one next to it, which is an output reference, which I'm going to go ahead and make my red light. Okay, so what I'm going to do is I'm going to seal in the red light. So I'm going to use the red light bit in the relay module card, which, as you can see, as I hover over there, you can see, right, that's an alias for the relay that's bit 0 of the relay card, which is in module 3. And so that's going to be my seal-in. And so you can also see it's actually here telling you that the stop button is a 1, because of course it's already pre-wired as a 1 or closed. So a 1 indicates that that switch is closed. A 0 indicates that the switch is open. And so now what I'm going to do is I'm going to select a B OR bit or box here. So this is a function block. In this case, it's simply an OR. And let's see, yeah, I deleted them off there. But this is the OR. Now this has 4 inputs into it, but I don't want 4 inputs. So I'm going to click over here on this dot, dot, dot and open up the properties to the box, and I'm going to disable because I only want 2 inputs there. Okay, so and I'm going to kind of drag this down here. I'm actually going to run my stop bit up top, and I'm going to connect the start bit into one of the inputs of the OR, and I'm going to connect the red light into the other input. Or actually, let's see, I'm going to connect the red light to the output, and I'm also going to connect the output over here. So this is a feedback loop. All right, and this is my seal-in loop. So let me just go over that. I'm going to delete this. If I click on it, I can hit the delete key and delete those. All right, so I'm going to have, of course, my output of this OR. Actually, I'm sorry, I need my AND box too. So I'm going to select a B AND. Now the B stands for Boolean or binary. All right, and so I'm going to have my AND. And again, I only want 2 inputs for this right now. So I'm going to open that up and uncheck the others. So this is going to be my stop bit. So remember to start a seal-in circuit, you need to press the start button, and of course the stop button must be closed, right? So the start switch or button must be closed and the stop switch must be closed. But the stop switch is closed. But so we have to have both of those. So that's an AND condition. Or we have to have the system already sealed in. All right, and so I'm going to connect this output. So I click on there, you come over there, you see the green dot, I connect those, those are attached. And then I'm going to take the output of this OR is going to feed into the input of my AND. And then I'm going to also click on here and I'm going to feed back here. This is my fill-in. Now, so this is my fill-in circuit, and what's filling it in is this feedback line right here. That's what's sealing that in. So I'm going to go ahead and I'm going to click on the Who Active and select my PLC, which isn't plugged in, so I'm plugging it in here. While I'm waiting for that to come up, I'll plug this PLC in so it can talk to it. I'm going to go ahead and close this window again to give the PLC a moment to wake up. And then I'm going to connect to it again. And I'm going to drill down to the PLC 00, the processor itself. And I'm going to set that as my project path. Close this window, and I'm going to come over to this window and select download. I could have hit download on that previous window. All right, so I'm going to download this. Now, this is actually going to fail, but I want you to see the error that it gets. All right, and so there's my error. So my error is something called the resolve the loop by changing the data flow. So this is the loop here. This is what causes the fill-in. But the problem is that the inputs to the OR box over here, the inputs are looking for a 1 or a 0. And the problem is that they don't know what that is for input 2 because they don't know what the output was yet. So you kind of get this chicken and egg, issue going on. Which came first? And so you need to resolve that. And that's the error that we're getting here is because both of these boxes are tied into this loop. They're confused. They're confused about, well, wait a minute. I don't know what input 2 into my OR box. I don't know if that second input is going to be a 0 or a 1. So we have to make an assumption. So if I click on this wire and I right click, notice it says assume the data is available. And so we actually have to tell it assume the very first time. Remember that we talk about the cycle times of a PLC. So we only have to do this the very first time for the program to start up. Once the program started, then it's going to have the data from the previous loop or previous cycle. But right now, the very first time, it doesn't know that. So what we have to do is we're going to say just assume we know it. And of course, it's just going to assume it's a 0 is what it's going to assume. And so notice now there's right here at the input, you notice if I click off of it, it looks like almost there's like 2 double arrows there. That's telling you that you're assuming that. If you come over here, you can uncheck it and unassume it. All right, but you won't be able to compile the program if you do. So I'm going to leave it checked, and I'm going to come over here, and now I can download this to my PLC. And it's in program mode, so I need to make sure I go back to run mode. So I'm going to switch back to run mode. So now notice this whole thing turns green. So you know right away that you are actually running. And notice that, again, the stop button up here is a 1. The start button is a 0. So we're assuming the AND box over here had a 0 out. That was our assumption. So therefore, our OR box has a start button is 0. The output of the AND box is 0. So 0 or 0 is a 0. So the output is a 0. So then we go into our AND box, and we have the stop, which is a 1 because the stop is wired as normally closed. So it's a 1, but the output of the OR block is a 0, so a 1 and a 0 is a 0, and so my red light output is also a 0. So the output of this block is a 0, so my red light is not on. All right, so here is the PLC. So this is the Compact Logic L23E PLC, and we have it wired up over here to our switches and our lights. Now the amber light is on from the program it was running previously, and we never shut that off. All right, but the red light, as you can see up here at the top left, is the red light. It is off, and I'm going to press the button. Okay, I want to make sure that we can kind of see here when I switch back. So you should be able to see now when I press the green start button, you see that it turns 1 on the screen. I'm not seeing that. Okay, so what that means is, though, even though this is green, I left out a major piece here. We're not executing this code. This code is not executing, which is why we're not seeing it change. So I totally forgot that piece. So I'm going to come back over here. What I need to do is, it's running the main routine. Okay, so it's running the main routine, which, as you can see, is just nothing but empty ladder logic. So I'm going to go offline, and I'm going to come over here. Now I'm in my ladder logic now. I'm going to add a rung here, and on this rung, I'm going to come over to let's see, where's it at here? Program control. So I'm going to come over to program control, and I'm going to choose jump to subroutine. And I get this box here now, and then if I click on this, you can see that I have 2 routines to choose from. Well, I'm in the main routine, so I can't really choose that. It wouldn't make any sense. But I'm going to choose here my function block. And then we have these input parameters. I'm not using any input or return parameters here because I'm just using the tags. And so I'm going to remove these. So I just right click over here and remove. You got to remove them one at a time. And so I'm just going to call my subroutine. So that's the piece that I was missing. So now I'm going to go down here and I'm going to re-download my code. So notice it's running the main routine, and then this jump to subroutine is going to call the function block routine. And so now you can switch back between these two when you're running. But now if I press the stop button, so if I press the stop button, you should see that open or close. All right, I realized I've downloaded this to the wrong PLC. Okay, so sorry about that. Yeah, that jump to subroutine was a major issue also, but my biggest issue actually turns out to be that my PLC must have not been booted up, the one that I plugged in, and so I actually just selected the one that was showing at the time, which was a different PLC. So I downloaded my code to the wrong PLC. Okay, so we'll download it to the correct PLC and we shall try this again. So yeah, now you can see the stop button turning to 0 when I press it. So when I press the stop button, all right, you can see it toggling between a 1 because it's normally closed. So when I press and hold it in, it's a 0. And then when I press the start button now, you're going to see that the start tag gets a 1 value, which is going to send a 1 to the OR. So the output of the OR becomes a 1. We already have a 1 at the stop, so we get a 1 and a 1, which makes the output of the and a 1, which means that the red light's going to turn on. And then it's also feeding the 1 back into the OR, so even when I let go of the start button, it will stay latched. All right, so there you can see the 1s here right at the output of these boxes. You can see that those are 1s, and so the system is being sealed in, and then you can see the red light is on. If I now press the stop button, that turns to a 0. 0 and a 1 is a 0, which makes the output a 0, and I break the seal in. So this is a seal in for a FunctionBlock program as opposed to a ladder logic program. So it's still a seal in circuit. All right, we press the green button, seals in holds the red light positive, the bit inside of the relay for the red light, and uses that as the seal in bit. Press the stop switch, goes 0, and the light goes out. Okay, so your standard seal in circuit, but with a function block diagram. Again, I don't really recommend seal in circuits being done as function blocks. You might as well just do those in the ladder logic. But I just did this demonstration so that, because you're very familiar with this circuit in ladder logic, so that you can see the analogies and the differences between ladder logic and function blocks. Okay. Now, if you wanted to do a timer in the function block, you can come over here and you can grab a timer block. Now notice, we know if we look at our program tags, right, when you create a timer in ladder logic, it gets a data type of timer. However, if I come over here to my function block and I wanted to say throw a timer in here, then when I grab a timer block, such as a timer on block here, this is a completely different block than we had at the up here. If we look at our tags, notice that I have my Boolean. Remember, in this software, you really, a lot of times you got to come up here to the sides and widen these so you can read it all. So notice that we had a function block diagram Boolean OR. We had a function block Boolean and we have a function block timer. Because I added that timer. So every time you add a function block, when you look at your tags, you get that block showing up here. But if we look at the function block timer information, right, it has a pre-value, it has a reset value, it has an accumulator value. Okay, the reset is just like an input bit. That's all that is. It has an enable bit, TT, timer timing bit, a done bit, just like a normal timer on. All right, but we can make these available through these inputs here. So notice here, here's my timer enable. So what I'm going to do is I'm going to take the output of my seal-in bit and use that to enable my timer. And the pre-value, okay, right now you see the pre-value is an input. Well, if I come over here, I can uncheck this as an input. Notice the I's for inputs and O's for outputs in this first column over here. And I can just put in a value here, say 500, right? Half a second, 500 milliseconds. And I can just hard code that. And then I can take my done bit, and what I'm going to do is I'm going to copy this red light down here, and I'm going to turn this on as the amber light. So I'm going to make this amber light come on. Okay. And then the reset, I'm going to get rid of the reset. Okay. And so when I run this now, after half a second, the amber light will come on. So you'll see this. Actually, I'm going to change the accumulator time. I'm going to change it up to, say, 3 seconds. Just to give me a little bit of time to talk while this is running. So I'm going to download this. And I want to see the accumulator value. Now, I'm not doing anything with the accumulator value. So you can see it starts at 0, and the done bit, the timer is not done. When I press now, when I press the start button, the timer starts timing. So you can see the accumulator advancing, and then when it hit 3,000, it went to a 1, and you see that the amber light came on. So that's the timer. Now the issue with that timer though is we we can't change while this is running. I don't think I can actually come in here and change this. Let me see if I can. Some of the values I know you can't change. I might be able to change the preset value. 1001. Yeah, so I did take a change in that. However, you can't change it with a tag or with an HMI or anything like that. So I'm going to go offline here for a minute. And I'm going to come over to my tags, and I'm going to create a tag which is, I'm going to call my timer preset, which is going to just be an integer type. All right, and I'm going to come over to monitor tags, and I'm going to set the initial value of that to be, say, 5,000. And then I also want to do my, I want to be able to reset this timer. So what I'm going to do is I'm going to use my selector switch. So I'm going to use my right selector switch, which is local, :1, input.data.2. It's the second bit in my DC input module. And so I'm going to set that. So now I'm going to come back to my function block, and I'm going to allow the preset value to be an input. Okay, so I'm gonna reset it back to 0, although it doesn't matter because the input's going to override what it is. And then I want my reset, so I'm also going to enable the reset here. And so there those are. So now I need an input tag here, which is going to be my timer preset value, which is 5,000 currently. And then I also need another tag. You can copy it or you can drag it down, either way. This is going to be my reset, which is going to be that selector switch. Okay, and so I'm going to stick that in there. And so I'm going to go ahead and download this again. Now remember, it's based on, to enable the timer, you have to have the seal-in enabled. So right now that's not enabled. So I'm going to enable my seal-in. So now you see the red light is on. I've enabled my seal-in, but the timer is still not moving. Okay, the reason the timer is not moving is because my selector switch down here is turned all the way to the right. Okay. So angle that down just a hair. And trying to show both. You can just see the red light in there. Maybe if I make it slightly larger. But we can see the red light in there. But now if I turn this over, then the timer starts timing. If I go back over here, it resets the timer. Okay, now the selector is 0, and then after 5 seconds, it turned on the amber light. Okay, I can disable the system. Now the selector switch is in the 0-bit position, so it's timing. If I flip it to reset, I can reset it before it actually timed out and turned on the amber light. Okay. All right, so that is the timer inside of a function block. So let me just go offline here and just talk about some of these others. I'm not going to demonstrate them all, but I just want to at least discuss some of these other blocks that are available. So, you know, you just come through here and you look here, there's a B not bit, which will negate your values. Okay, so if it's a 1 and you want to make it a 0, you can use a B not, and that just negates it. So that one's kind of important. You have an exclusive OR. You can multiply, add, subtract, multiply, divide. There's a lot of different things for various controls. Some of those we'll talk about later. There's some filter circuits here. There is some select values in here. There's a multiplexer. What the multiplexer does is it allows you to select, like if I, well, let me just grab it here so it won't disappear on me. So this right now, it'll take in, you have 8 possible inputs, and then your selector selects which one of those 8 inputs you want. And then the output, it'll basically pass, based on your selector value, it'll pass that through. So so there's the multiplexer. You can do a lot of different math. There's a moving average and just a lot of different other terms and min-max values here. Of course, you know, you always have functions for alarms, some one-shots. Okay, so if you need one-shots, timers, we already kind of discussed. You have your normal timers available to you. You have some compares, some like mathematical compare values, some various mathematical functions, multiply, divide. Well, you know, you saw the first ones of those before under the favorites tag, but you know, absolute value, move statements, and this is where, you know, the B and B or are also under here, but they give them to you under favorites because they're used a lot. You also have the opportunity here to jump to subroutines, to jump to other programs. And kind of as we saw with the ladder logic here, we're jumping from ladder logic to a function block diagram. We could just as easily create another new routine over here that is one of the, you know, what other types, another ladder logic, a sequential diagram, structured text, whichever one that you want. We could go in and create any of those and jump to those from any other program. So that's kind of what's happening there. Trigonometry functions, if you want to do that. Some logarithmic type functions. So there's just lots and lots of different choices here on these function block diagrams that are available. So, you know, you can, one thing that I want to point out, if you click on these and press F1, it will pull up the help so you can read about these and read. They tell you about all the different input parameters, the output parameters. They give you a description. They even have a timing diagram. So, you know, and this is actually true for the ladder logic too. You just click on something and press F1 and you will get help on that, and you'll get a lot of different information about the different blocks. So if you're not sure like what this is going to do, click on it, bring it out here, press F1, and then you can read about it and all the different options and choices and things that it gives you. And if you decide that you didn't want that block, just delete it and it'll disappear. All right, so again, let me just kind of show you the connections here. If you highlight one of these, you delete it, and then you just click on and you hold your finger down and you drag it around until you get to a point where you can connect it and you'll get a green dot. Now, inputs, you should never have two inputs connected to the same, two lines from two different places connected to the same input. You need a unique input for each one. But as we can see over here at the outputs, you can drag or connect multiple, come from the output and go into multiple other inputs. Okay. So that's kind of it for function block diagrams.